forces are blank and blank, and as I go through and release, delete the colored things, you write in anything I draw, you draw, bring them for a stamp tomorrow. So forces are pushes and pulls. So anything that's pushing on an object, pulling on an object is a force. Forces have direction. Forces have size. So because they have direction and size, we use vectors or arrows to represent them. Directions, just like motion, can be positive, which we usually consider going to the right, or negative, which we would consider going to the left. So draw a force vector that is going in the positive direction. So a vector in the positive direction would look like this. So draw in, oops, let's not do that. Where are you going? Here. There we go. Nope, this is funny. Okay, there we go. So draw in, boy, this is going to make us dizzy, isn't it? Okay, so from now on, I'm not going to draw it. You're going to have to draw what it asks. Pause as you go, as you need. So forces always come in pairs, and we have balanced forces being a pair of forces that are equal and opposite. In our tug-of-war computer simulation, we had balanced forces acting on the cart, so please draw a set of balanced forces on this object. Balanced forces have a net force of 0. A net force is the total or sum of all forces acting on the object. In the computer simulation, when you hit that little sum button, it would give you what the net force is when they were compared. Forces, pairs of forces acting opposite of each other, are subtracted from each other. Pairs of forces acting in the same direction are added together. Forces acting at angles to each other are not pairs of forces and would not be considered. So the net force of the pair of forces here, we have 5 going to the right, which would be considered positive, and we have 5 going to, or 10 going to the left, which would be considered negative. So we would combine those and get the net force, right? The net force right here. The net force now for the other pair, instead of going towards each other, now they are working together, working the same direction. So combine them, write the net force here. Unbalanced forces are a pair of forces that are not equal and opposite. In your tug-of-war computer simulation, you had forces that were also unbalanced. So draw a pair of forces that are not equal sized and opposite direction. They have to be opposite direction, just not the same size. Unbalanced forces have a net force that is not 0. So you combine them, you're going to get an answer greater than 0. You might get a negative answer. Unbalanced forces will always change the motion of the object. Unbalanced forces, where one force is larger than the other, will cause an object to speed up, to slow down, or change direction. So here on this object at the bottom, we have an object that is being pushed to the right with this force. So before the force acted, this object was moving to the right. So draw a force diagram to show what's going to happen to this object. What's the motion going to be if it is moving to the right and being pushed to the right? So now we've got other forces here. We've got this object. Draw the motion map of an object with the following forces acting on it. Before the forces acted, this object was moving to the right. So this object was moving to the right. Our motion map has vectors to the right, but it's being pushed to the left. So when we had the push-o-meter demonstration, what happened in this case? And then here, this object is also moving to the right. These forces are balanced. So draw what the motion map is going to look like if the forces are balanced. There are four kinds of forces that we show on a force diagram. The force of gravity is caused by the pull of the earth. Gravity is always a pull, and it always is straight down. So draw a gravity vector here and label it. The normal force is the upward force of any surface on an object it's resting on. If the object is on a surface that is and the object is not moving up or down, the normal force is always balanced with the force of gravity. So draw a normal force and a gravity force on this object. The force of friction is always acting on a moving object, and friction always moves in the opposite direction. So these down here now are about friction. So if an object is moving to the right, friction is acting to the left. So this object is moving to the right and slowing down. Draw what the vector for friction would look like. If an object is moving to the left, friction is to the right. So this object is moving to the left. Draw a force vector for the friction causing this motion. Make sure you're labeling these as FF, force of friction. If an object is moving up, friction is acting down. If the object is moving down, friction is acting up. Draw a force vector for friction causing the motion below. We have an object moving up and slowing down. Friction is always going to try and slow the object down. So friction is a stopping force. Any push or pull on an object is the applied force. Applied forces can act in any direction and can balance or unbalance any force. Sometimes you need to put in the applied force. If you have something moving across a table, but it has constant speed, that means friction has to be balanced if it's going to have constant speed. So on this object here, show gravity, normal force, force of friction, and the applied force if the object is moving to the right at a constant speed. So do the motion map right here, and draw all of those forces. The last part of the notes, I want you to identify if these situations are balanced or unbalanced. Write a B for balanced or U for unbalanced in the following situations. 2 students push the desk at the same time and in the same direction. 2 students push with equal forces acting in opposite directions. The force of a kick makes the ball move faster. The girl pulls the dog to slow it down. The bat changes the direction of the ball. Pushing and pulling on the clay changes its shape. A Formula One racing car is accelerating from the starting grid. A cyclist is braking. A person is resting in an armchair. A truck traveling at a constant speed on a straight road. Please bring these. They will be stamped and we will go over them. Have a good night.